So I'm going to start out class by making just a few announcements, none that are new, hopefully, but they're very important. And I will send an email out this afternoon before I leave work, just because there's stuff going on this week and I want to make sure that everybody's on the same page, given attendance or not, as the case may be. So the first thing that I want to say is section 2.1 is due on the 12th by midnight. 2.2 is due on the 14th by midnight. We're going to finish up 2.3 today, most likely. So that will be due on the 17th by midnight. And you have a quiz on sections 2.1 through 2.3 in class this Friday. This announcement was made on Friday of last week. So now, one thing that I have for you is I have an optional worksheet on chapter 2 that I printed out hard copies. So if anyone would like a hard copy of it today, I'm happy to give that to you. What I want to do, though, is share my screen. Not that anyone's on Moodle or on Zoom right now, but for those people who will hopefully be accessing it later, if you want to do that chapter 2 worksheet for extra practice, if you go to class activities and projects and you scroll down, there it is. There's your chapter 2 worksheet. Okay, so if you don't get a hard copy in class, you sure can get a copy of it online. You don't have to do it. It's there for practice, and I strongly encourage that. And I will post answers as well. Cool. All right. So again, this is in the on the Moodle page under class activities and projects. In terms of the quiz this Friday in class, yeah, you can have a sheet of paper with notes. Now, what I'm going to be doing is I'm going to be finishing up section 2.3 today. And that won't take us very long. Okay. I want to answer any online homework questions then. And then if we have time for me to start 2.4, I'll start it. 2.4 is not on your quiz, nor will it be on your second test. It's just some information that is really important for you to be aware of and for me to convey to you, but it's not anything you need to be tested on in the college algebra course. Okay. So essentially what my plan is today I'm going to finish up 2.3. If anyone has any online homework questions thus far in chapter 2, please ask them. I'm happy to spend the rest of class today answering them. If there are no questions, then I'll jump into 2.4. And then on Wednesday, what I'll do is finish up 2.4 and then also answer any questions you have. You with me? I'm trying to give like a good amount of time for you all to be able to ask questions and kind of take in the material. You okay? You're all quiet. What's up? Monday afternoon? Yeah. Okay. Well, probably once we start doing some math, things will liven up just due to the excitement of the mathematics. You like my sarcasm? Okay. So, oops. Huh. Don't you dare fall down. Okay. There we go. So, what I would like to do now is continue section 2.3. And really what we have left in 2.3 are a couple more word problems. 2.3 is all word problems. Okay, because the whole point of doing this modeling is so that we can look at it in the context of real life. All right, so suppose we have 2 window washing companies. Company F charges people $5 per window to clean. And company S charges $40 just for coming out. And then they charge $3 per window. So you could have company F come over, shoot the breeze with them, not do any windows, and you wouldn't have to pay them anything. Okay, so do you agree that at least initially, company F is going to be cheaper? I mean, let's look at it. If you have them come and wash 2 windows, how much will company F charge you? $10. If you could have company S come out and wash 2 windows, how much will you have to pay? Not a rhetorical question. You'd have to pay $46, right? You have to pay them $40 for coming out and then $3 per window. So initially, company F is cheaper than company S. Okay. But for example, if I get to like, suppose I have 40 windows to wash. Okay. So if I had, say, 40 windows to wash, wouldn't company F charge me 5 times $40 for $200? That actually seems like a screaming deal. 40 windows on like a high rise is a lot. On the other hand, for company S, if they came out and washed 40 windows, well, we'd have to pay $40 plus 3 times 40 windows. So here that's 40 plus 120. In this case, company S would be the cheaper route. So do you see how for a period of time, this is cheaper, but after a certain point, this company's cheaper? So what I want to know is this: how many windows will make the second company be preferable? From the consumer standpoint. In other words, we don't want to pay more money than we have to. It's a reasonable question to ask. I mean, I think that this is extremely realistic in terms of practical day-to-day life. Well, what I would do is I would first write the function of both of those. Okay, these are both linear equations. Do you agree that my first window company, if I let X represent the number of windows washed, it would be 5X, right? $5 per window times the number of windows. How about my second company? Can somebody tell me what the equation would be to model the cost for there?
3x plus 40.
3x plus 40. Good job. Does anyone have a question how we got 3x plus 40? Right, $40 is just your base price. And then you add on $3 per window. All right, so what I would do here is I would say, well, from some point on, this second company is going to be preferable. Why don't we find out where they're the same? Right, because once we know where the charges are the same, from that point on, this company is going to be cheaper. How would we find out where these are the same? What would I do to these two equations? We set them equal, right? Same means that my first company is going to cost me the same amount as my second company. Can I solve this equation? Yeah, what would be my first step? Beautiful. We would move our 3x over by subtracting it from both sides. So we have 2x is equal to 40. Now what? Divide by 2. So we get x to be 20. In other words, if we had exactly 20 windows to wash, it would cost the same whether we use the first company or the second company. So at that point, you probably want to go to who is a nicer human being. It's usually how I make my decisions. Okay. So if at 20 windows, it's the same, at what, how many windows, starting at how many windows would this second company be preferable? Not a trick question. 21. Any questions there? Are you thrilled? So let me ask you this, since it's a quiet day. Is this thumbs up, thumbs down, or thumbs to the side? Okay. All right, let's do another one. Okay, so now what we're going to look at are home prices in Mississippi and Hawaii. And suppose we're given the following information. Suppose in 1950, the median home price in Mississippi is $25,200. And then in 2000, it was $71,400. Makes sense that it would increase, right? And in Hawaii, in 1950, the median home price was $74,400. And in 2000, it was $272,700. Boy, I'd hate to look at what Missoula's are. They're so ridiculous. Housing, that's the median.
I'm just saying like for an average, like 2-3
Yeah.
average place is like 400.
It's unbelievable. I just recently read that the median home price in Bozeman is over 800,000.
Yeah, I don't know what the median is.
No, it's crazy. So in case anyone's wondering, when we talk about like average home prices or average salaries and you look that up, it's not the mean value that's given, right? The mean is the average. What they give you in terms of statistical data online is the median. That's the middle value. So in other words, like in Hawaii here in the year 2000, half of the houses were more expensive than this amount and half were less. In case you're curious what the difference between the median and the mean is. All right. So what I'm going to do is I'm going to let T stand for the number of years since 1950. And what I want to do is I want to find the linear function that represents how the home prices are changing in Mississippi. And then I also want to do the same thing in Hawaii. Now, I let T be the number of years since 1950. And I did that very intentionally, okay? The reason why is because then isn't the value in 1950 my y-intercept or my starting value? Right? If T is the number of years since 1950, doesn't this give me the ordered pair 0, 25,200? And then down here, the 71,400, how many years after 1950 is the year 2000? 50 years. So don't we then get the ordered pair 70 or 50 comma 71,400? Do you see how I got these ordered pairs from the way I'm defining my variable? Well, let's find the slope of this line. How do we do it? Rise over run. So we take the change in our y values over the change in our x values. You're going to get 924. I did the computations ahead of time. What would be my corresponding ordered pairs for Hawaii? Ooh, be careful. We're talking Hawaii now.
Oh, so yeah, 74,400.
Perfect. And what would be my other ordered pair? 50 and then 272, 700. Questions here? So can I find my slope? One hopes. So 272, 700 minus 74, 400 over 50 minus 0. And this is nuts. So check this out. Over the 50-year period, what this slope tells us is that on average, the home price increased by $924 a year. Contrast that with this. On average, the home price increased by $3,966 per year. Seems like it would be a lot less expensive to live in Mississippi than in Hawaii. All right, so let's write the equations of these lines. I'm going to call M of T for Mississippi and H of T for Hawaii. Can somebody tell me what the equation is for my Mississippi home? Well, what's my slope? Yeah, 924 T plus, what's my y-intercept?
25,200.
You got it. Ross, you rock. You with me there? Are there questions how we got this? You got to ask me. Okay, given that, somebody tell me what's my equation for Hawaii? Awesome. Thank you, Eric. I love when people talk in here. And I know people can be shy, but it's all right. Well, now that we found that really interesting information, I'm going to ask 3 questions. My first question is, which state increased at a higher rate? I think y'all know the answer to that. Who increased at a higher rate? Hawaii, totally. Compare my slopes. Okay, what is the median home value in Mississippi? How about in 2022? Can we find that? Well, we're going to go to the Mississippi equation. What do I plug in for T? Do I plug in 2022?
72.
Good. Notice T is defined to be the number of years since 1950. Right? So 2022 minus 1950 is 72 years. So we would find M of 72. And assuming that it followed the same model. Now models change after periods of time. But assuming that, wow, you couldn't get anything in this town for that. 91,728. Can't even get an apartment for that. When were the median values the same? This is a cute one. How would we find when these two states had the same median value? What would we do? Beautiful. We would set the equations equal. We want to know when the median home value of Mississippi is the same as the median home value of Hawaii. So we would say, well, when is 924T plus 25,200 equal to 3966T plus 74,400? All right. First step, what do you want to do? We got to solve this. I mean, how are you going to sleep tonight if you don't know this? Okay, beautiful. We can move all of our T's to one side. So we could say 3966T minus 924T. And that should give us 3042T. What's going to be my next step?
Subtract 7,400, 74,400.
Totally. Now we'll scoot our 74,400 over. So we're going to get 3042T is negative 49,200. Last but not least, divide both sides by 3042. And I claim you get about negative 16. So if T stands for the number of years since 1950, what does T equals negative 16 tell us? T is the number of years since 1950. So if we get a negative value for T, doesn't that mean that instead of going since, we're going prior? In other words, 16 years before 1950. So approximately in 1934. Wasn't that kind of cute? All right, so that finishes up section 2.3. I've tried to do homework problems pretty darn similar to what you're going to see. So are there, hold on one second. Are there any questions on this? So what I'm going to do is share my screen online. I am going to assign section 2.3 for a week from today. All right. So, yes. Awesome. I mean, not awesome that you were confused, but awesome that you're asking questions. Okay. So what I want to do right now, and for the rest of class, if this is what we're going to do, this is totally cool. What are your questions? So we have 2.2 number 9. What other questions do folks have? Happy to do more. So, do you want me to do your version of question 9, or should I do whatever comes up for me? Okay. So let's look. 2.2 number 9. Is a lot of homework. Oh, did I just, yeah, this is 2.2. And one comment following these things is, so number one, I would never test you on a question like this, but it sure is kind of cute. But anyway, if as you're putting graphs in, you get marked wrong, but your graph seems correct, please hit message instructor. Okay, because if you have a point indicated when they didn't want a point indicated, even though the point's on this still in line, they'll mark you wrong. It's just random. Okay, so what we want to do is we want to complete the description of the piecewise function graphed below. Okay? In other words, we want to find the equation of this line. We want to find the equation of this line. And then we want to find the equation of this line. Notice they're given the broken down domains. So for example, this is from -6 to -3. And would you grant me that that corresponds to this line right here? Okay. And then open circle -3, close circle 2, that corresponds to this line in the middle. And then open circle at 2 through 6. Okay. So what we want to do is one by one go through these functions. I'm going to do the middle one first, because I might as well start out with the one that, at least for me, requires the least amount of work. This is a constant function. What is this constantly equal to? 2. Does that make sense, Eric? Okay. So the issue that we have is that we need to find the equation of this line and that line. So let's look at this line right here. Now, we don't have a y-intercept to read off. So probably what we're going to want to do is we're going to want to find 2 definitive points on the line. In other words, where it crosses perfectly without a decimal approximation. So like right here is a good point to look at. And this is another very definitive point. So this point here, would you grant me, is -5, -2? And then this point here is -3, 3. Okay, I'm gonna stop sharing my screen for 1 second. What would be my first step to find the equation of this line? Wouldn't we find the slope? Okay, slope is change in y values, so 3 minus a -2 over the change in x values, -3 minus a -5. Minus a negative is plus a positive, so we get 5/2. Okay. Now, I need to find my value of b. How do I find my corresponding value of b? Well, we got 2 ordered pairs. Can't we take one of them and plug them in for x and y to get our b value? And it doesn't matter which ordered pair we plug in. Neither one of them is that much nicer than the other. So why don't we plug in -5, -2? So I'll plug y is -2 when x is -5. So I get -2 is -25/2 plus b. And to solve for b, I would add 25/2 to both sides. So we have -2 plus 25/2. Well, -2 is -4/2. Plus 25/2 is 21/2. Does that make sense so far? Okay, I'm going to share my screen again, if that's okay. And they wrote it really yucky. I wouldn't write it the way they did. Yeah, so check out what, if you multiply this out, you're going to get the same thing. It's dumb. They shouldn't have it like that. Yeah. Yeah. I mean, essentially what they said, the way they were doing this, let me explain. is they were using the shifts that we talked about in chapter 1. They computed the slope of this line to be 5 halves. And so that would be going through my origin here. And then notice that it was then shifted, they shifted it left 3 and up 3. I wouldn't do it that way. Do it my way. Do you want me to go through this last one too? Okay, so you're gonna want to do a similar thing. Let me just see, did they put, yeah, they did another stupid way of doing it. Don't do it their way. You won't get marked wrong if you put it the way we did. Are there other questions? Well, I have about 10 minutes of talking to do in section 2.4, maybe a little bit longer. We have about 9 minutes left in here. Do you want me to start it today, or do you want to wait and start that Wednesday? I can I'll give out the worksheets right now if you want.
I'll take a worksheet, please.
Okay. Yeah, let's